So here's our problem. April runs a 25-kilometer race. She passes the first 8-kilometer checkpoint in 45 minutes and finishes in 140 minutes. Determine whether the distance she runs is proportional to the time she spends running. In this first approach to the problem, we'll use a graph. And the key idea here is proportionality. Is this a proportional relationship between distance and time? So students need to understand, what does proportionality mean? Well, what it means is that the phenomenon in question is happening at a constant rate. A constant rate. And we'll get more into detail about exactly what that means. The other part of it is that the phenomenon starts at zero, I'll say, which basically in this case it means if April runs for no time, she'll run no distance. There's no kind of initial distance that she starts. Zero time means zero distance run. So those are the two qualities about proportionality, and there's a lot more to that as students get into this, but we'll leave it at that for now. And mentioned that in the case of a graph, the constant rate means we're looking for a straight line or a constant slope. The rate is the slope, the steepness of the line. So we're looking for that to be constant. And the starts at zero means the line needs to pass through the origin. So let's graph these two relationships that we know and see what we find. We'll begin with the coordinate system. And as is conventional, we'll put time on the horizontal axis and distance on the vertical axis, which means that our slope, which is going to be the rise over the run meaning the x, it's going to be y over x, is going to be kilometers over minutes, or kilometers per minute, which is a speed. So our slope is going to be that actual rate that we're looking for. So for the first part of the race, it takes April 45 minutes, and we represent this horizontally by moving over to 45 on the horizontal axis. And in that time, she runs 8 kilometers. So our 8-kilometer checkpoint can be represented by this dot here, 45 minutes to run 8 kilometers. Now if we look at the entire race, that takes 140 minutes. So she'll run 140 minutes, and in that amount of time, she's going to run 25 kilometers. So the question is, do these two points lie on a straight line through the origin? There are two ways to do that. One is to draw a line through the 2 points and see if it hits the origin. And the other is to draw a line from the origin to each of these points and see if they are the same line. They're on top of each other. We're going to use that second approach. We'll start with a line from the origin to the 8-kilometer checkpoint, which represents the distances and times that April would be running if she were running at a constant rate from time 0 to time 45 to the first checkpoint. So she would be running, basically this represents that path. To represent the overall race, we are going to look at a line that goes, again, we'll start from the origin and draw a line to the end of the race, which represents her running 140 minutes and running 25 kilometers in that time. And our question is, are these two lines collinear? Collinear means on top of each other. They have the same slope and they're in the same position. Well, it's a hard thing to tell if you're just looking at the graph, particularly if you didn't draw it very well. Are the distance and time proportional? Are these the same line? Well, they sure look like it from this point of view, but we can't be certain. So our answer is maybe. And what we need to do to really determine this is take another approach that's more specific. So this particular situation, it's not really definitive whether or not the two are proportional. It depends on how accurately you've drawn the graph.